Now let us calculate the balance factor for this given binary search tree. Now let us redefine the height of the binary search tree, which is slightly different from the earlier that we had. Earlier we had that the root is at depth 0. Now I am going to change that the root is at depth 1 for the purpose of self-balanced binary search tree. Okay. A tree that consisting of a single node is at depth 1 and the height of that tree is 1. Okay. According to this definition, let us define the height of the binary search tree for every node in this example. So, the height of the leaf node is 1. Okay. And because it is considered at depth 1, and then let us calculate the height is of this node is 2, this node is 3, and then this node is 4, and for this node is 2. Okay. Earlier we had the definition, the longest path from the root node to the leaf node. The longest path is this, and we have taken the number of edges, which is nothing but the depth. So earlier the height of the root node was 3. Now according to the new definition, the height of the tree will become 4. In the same longest path, we are counting the number of nodes. The number of node is nothing but 4. So for this, now let us calculate the balance factor. So let me draw the tree first, and then we apply the formula to calculate the balance factor. Now, according to the definition, balance factor is height of the left subtree minus height of the right subtree, and take the absolute value that should be less than or equal to 1. So, the meaning of this, the difference between the height of the left subtree and the right subtree is not more than 1. Okay. And let us calculate the balance factor for this leaf node first of all. All the leaf node does not have any left and right subtrees. So the balance factor for all the leaf node will be 0 because there is no left and the right subtrees. And then let us calculate the balance factor for the node 4. Okay. So the left subtree is at height 1 and it does not have any right subtree. So 1 minus 0, which is 1. And for this, left subtree is 1, right subtree is 2. 1 minus 2 is minus 1. And then for this node, left subtree is 3, right subtree is 2. 3 minus 2 is 1. So these are the balance factor. Now for this node, left subtree is 1, right subtree does not have any right shell, so the balance factor for this node is 1. Now you see, balance factor for every node is either 0, 1 or minus 1. So it satisfies the property which is defined over here. Hence this binary search tree is said to be self-balanced, or we can say that it is in the balanced binary search tree. So the motivation or the main idea of the self-balanced binary search tree, wherever the property of self-balanced binary search tree is violated, for that node we are trying to make that tree become balanced by itself. That is called self-balanced binary search tree, by adjusting the height of the left subtree and the height subtree. So that is the main motivation of the self-balanced binary search tree. Now let us consider what is unbalanced binary search tree. Now let us consider the same tree but with a slight modification. I have removed the left child of 8. Earlier it was 7, and then I have additionally included the right child for the node 4, which is 5 over here. Now let us calculate the balance factor. Balance factor for the node 5 is 0 because it is a leaf node. Earlier balance factor for this 4 is 1. Now look at the left subtree and then right subtree, 1 minus 1, which is 0 now. And then balance factor for node 8, since node 8 is a leaf node now, the balance factor now it will be 0. Now let us calculate the balance factor for 6. 3 minus 2, sorry, this is at height 1, right? Okay, so earlier it was 2, so 3 minus 1, which is 2 now. Okay, now you see this, according to the property of the self-balanced binary search tree, any node should have a balance factor of -1, 0, 1. Now this node is violating that condition, so the whole binary search tree is now unbalanced. Now the idea, as I said before, we are trying to make or adjust this node so that the balance factor will become in between 0 to, or in between -1 to 1, -1, 0 or 1.